All right, so I wanted to make a quick video on how to use O2 sensor data in your diagnostics. On our screen, we have pulled up the O2 sensor that's before the catalytic converter on the side of the engine that has cylinder number 1, right? So O2 sensor bank 1, sensor 1. And then we have O2 sensor bank 1, sensor 2, which is behind the catalytic converter on that side. And then here's the O2 sensor on the other side of the engine before the cat, and then this one after the catalytic converter. All right. So the ones that are before the catalytic converter, these two right here, their job is to feed information to the computer about what is in the exhaust so that the computer can make adjustments to our air-fuel ratio, right? So it's either adding or taking away, and the way it knows how to do that is when we're reading in the low, like 100 millivolts, it's telling the computer we're running lean, so the computer's gonna make the adjustment by adding fuel, and we should see that in our short-term fuel trims. Okay, if we see it stuck a little, or if we see it go high, like around 800, 900 millivolts, then it's a rich reading and it tells the computer we need to take away a little bit of fuel. And again, you can see that in your short-term fuel trims. So right now, they're working really well. We want to see it switching back and forth between rich and lean frequently, multiple times a second, because if we're doing that, that means we're crossing over the middle ground, which is 450 millivolts, which is stoichiometric, or 14.7 to 1. So if we're doing that, if our average is stoichiometric, that's exactly what we're trying to achieve. Okay, so these look really good. If I came in here and they were stuck in the low millivolts, like the hundreds, then we would have a lean running condition and the computer would be compensating by adding tons of fuel. If we saw it stuck high, then exact opposite, we have a rich running condition and the computer would be compensating by taking away fuel. Okay, but that's not the case here. Now, the O2 sensors after the catalytic converter, they have a completely different job. They work the same, but they're supposed to be here in order to tell the computer if the catalytic converter is doing its job. And you can see this one right here, how it's not really switching very much. It's going between 679 and 717, which tells us that if this is what was going in before the cat and this is what's coming out after the cat must be doing its job, right? We want to see a fairly flat-lined graph on our post-catalytic converter O2 sensor. However, on the other side of the engine, the other catalytic converter, you can see that that's not the case. This is consistently jumping from 600-700 millivolts down to 100 millivolts, and that tells me that the catalytic converter on this side is not cleaning up the exhaust very well, so it might be partially plugged. Okay, so you can use O2 sensor data to help you with engine performance issues, and you can also use the post-cat O2 sensors to help you decide if your catalytic converters are working or not. If you have any questions, just put it in the comments.